An oxidation number is the charge that an atom in a compound would have if the electron pair in the bond belongs solely to the more electronegative atom. Oxidation numbers always refer to single atoms. There are several rules to use to figure out the oxygen number for any atom within a compound. The first rule is that the oxidation number for any atom in an element is always 0. The oxidation number of a monoatomic ion is equal to the charge on the ion. So for example, Mg2+ would have an oxidation number of +2 because that's equal to the charge on the monoatomic ion. The oxidation number of each hydrogen atom in most of its compounds is +1. So for example, HCl, the hydrogen would have an oxidation number of +1, except hydrides, where they're -1. So something like calcium hydride, that would have an oxidation number of -1. The oxidation number of each oxygen atom in most of its compounds is -2. For example, water, that oxygen would have an oxidation number of -2. Peroxides are the exception. They are -1. So something like H2O2, the oxygen would have an oxidation number of -1. In OF2, it's a little bit weird. The oxygen is going to have a +2 oxidation number. The last rule is that in compounds, the elements of group 1, group 2, and aluminum have positive oxidation numbers of +1, +2, and +3 respectively. So if, for example, you had KCl, K comes from the first group, it would have an oxidation number of +1. The last rule that we really need to pay attention to is that the sum of the oxidation numbers of all the atoms must equal the apparent charge of that particle. So if you're looking at a neutral compound like KCl, we can use our rules to figure out that K has an oxidation number of +1. And then we can use the rule that the sum has to equal the apparent charge, or the sum of the oxidation numbers in this compound has to equal 0 to find the oxidation number for chlorine. So the only possibility is that if chlorine was -1. Two examples then. We've got CaO as our first example. What we're going to do is use our oxidation number rules to figure out our oxidation numbers. One of our rules tells us that the oxidation number for oxygen is always -2. So we can use that rule to say that oxygen is -2. And then we can use our rule that the sum has to equal the total charge on the compound to find the oxidation number of calcium. Because it's neutral, the only possible oxidation number we can have for calcium is +2. Gets a little bit more complicated when we get into polyatomic ions like the one shown here. If we come across this situation, again, let's start with the oxygen because we know what that is based on the rules for oxidation numbers. The oxygen has to be -2. Now to figure out the charge on the oxidation number for manganese, we have to use the oxidation number with the oxygen and know that the sum of those oxidation numbers have to equal -2. So we don't know what manganese is. Let's call it X. So we're going to have X plus 4 times -2 because we have 4 oxygens and we know that each oxygen has an oxidation number of -2. And we know that if we add those two up together, it should equal the apparent charge on the particle, which is negative 2. So we've got x minus 8 is equal to negative 2, meaning that x is going to be plus 6. And that is the oxidation number for the manganese. We can use oxidation numbers to identify if something is being oxidized or reduced. An increase in the oxidation number means that the atom has lost electrons and has been oxidized. A decrease in the oxidation number means that an atom has gained electrons and therefore has been reduced. If we take a look at the oxidation numbers in this example here, zinc would have an oxidation number of 0. Let's work through this. So the oxygen would be a negative 2. The sulfate polyatomic we know has to have a negative 2 overall. So that means that our sulfur is going to be a plus 8, and our copper is going to be a plus 2. Now if we do the same here, again, oxygen is going to be negative 2, sulfur is going to be plus 8, zinc is going to be plus 2, and the copper is 0. If we look at then what changes between reactants and products, the zinc oxidation number goes from 0 to plus 2. It's increased in number, meaning that this is our oxidation reaction. Our copper goes from plus 2 to 0. This then is our reduction because we have decreased in oxidation number.